Lockheed Martin F-22 Raptor is a fifth-generation, single-seat, twin-engine, all-weather stealth tactical fighter aircraft developed for the United States Air Force, U.S. Air Force. The result of the U.S. Air Force Advanced Tactical Fighter Program, the aircraft was designed primarily as an air superiority fighter, but also has ground attack, electronic warfare, and signal intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22's airframe and weapons systems and conducted final assembly, while Boeing provided the wings, aft fuselage, avionics integration, and training systems. The aircraft was variously designated F-22 and F/A-22 before it formally entered service in December 2005 as the F-22A. After a protracted development and despite operational issues, the U.S. Air Force considers the F-22 critical to its tactical air power, and says that the aircraft is unmatched by any known or projected fighter. The Raptor's combination of stealth, aerodynamic performance, and situational awareness gives the aircraft unprecedented air combat capabilities. The high cost of the aircraft, a lack of clear air-to-air missions due to delays in Russian and Chinese fighter programs, a ban on exports, and development of the more versatile F-35 led to the end of F-22 production. A final procurement tally of 187 operational production aircraft was established in 2009, and the last F-22 was delivered to the U.S. Air Force in 2012. Development. Origins. In 1981, the U.S. Air Force developed a requirement for an Advanced Tactical Fighter, ATF, as a new air superiority fighter to replace the F-15 Eagle and F-16 Fighting Falcon. Codenamed Senior Sky, this program was influenced by the emerging worldwide threats, including development and proliferation of Soviet Su-57 flanker and MiG-29 Fulcrum-class fighter aircraft. It would take advantage of the new technologies in fighter design on the horizon, including composite materials, lightweight alloys, advanced flight control systems, more powerful propulsion systems, and stealth technology. The Request for Proposals, RFP, was issued in July 1986 and two contractor teams, Lockheed/Boeing/General Dynamics and Northrop/McDonnell Douglas, were selected on October 31, 1986 to undertake a 50-month demonstration phase, culminating in the flight test of two technology demonstrator prototypes, the YF-22 and the YF-23. The program was managed by the Advanced Tactical Fighter Systems Program Office, ATF-SPO, located at Wright-Patterson Air Force Base. Each design team produced two prototype air vehicles, one for each of the two engine options. The Lockheed-led team employed thrust vectoring nozzles on YF-22 for enhanced maneuverability in dogfights. The ATF's increasing weight and cost drove out certain requirements during development. Side-looking radars were deleted, and the dedicated infrared search and track (IRST) system was downgraded from multicolor to single color and then deleted as well. However, space and cooling provisions were retained to allow for future addition of these components. The ejection seat requirement was downgraded from a fresh design to the existing McDonnell Douglas ACES II. After the flight test demonstration and validation of the prototypes, on April 23, 1991, Secretary of the U.S. Air Force Donald Rice announced the YF-22 as the winner of the ATF Competition 15. The YF-23 design was considered stealthier and faster, while the YF-22 was more maneuverable. The aviation press speculated that the YF-22 was also more adaptable to the U.S. Navy's Navalized Advanced Tactical Fighter, NATF, but by 1992, the Navy had abandoned NATF. Production and procurement manufacturers of the F-22 prime contractor Lockheed Martin Aeronautics manufactured the majority of the airframe and performed final assembly at Dobbins Air Reserve Base in Marietta, Georgia. Program partner Boeing Defense, Space and Security provided additional airframe components as well as avionics integration and training systems. F-22 production was split up over many subcontractors across 46 states to increase congressional support, though this production split may have contributed to increased costs and delays. Many capabilities were deferred to post-service upgrades, reducing the initial cost but increasing total program cost. Production supported over 1,000 subcontractors and suppliers and up to 95,000 jobs. The F-22 had several design changes from the YF-22. The swept-back angle of the leading edge was decreased from 48 degrees to 42 degrees, while the vertical stabilizers were shifted rearward and decreased in area by 20%. To improve pilot visibility, the canopy was moved forward 7 inches, 18 cm, and the engine intakes moved rearward 14 inches, 36 cm. The shapes of the wing and stabilator trailing edges were refined to improve aerodynamics, strength, and stealth characteristics. Increasing weight during development caused slight reductions in range and aerodynamic performance. The first F-22, an engineering and manufacturing development (EMD) aircraft named Raptor 4001, was unveiled at Marietta, Georgia, on April 9, 1997, and first flew on September 7, 1997. In 2006, the Raptor's development team, composed of over 1,000 contractors and the U.S. Air Force, won the Collier Trophy, American aviation's most prestigious award. The F-22 was in production for 15 years, at a rate of roughly 2 per month during peak production. The U.S. Air Force originally envisioned ordering 750 ATFs at a cost of $26.20 billion, with production beginning in 1994. The 1990 Major Aircraft Review led by Secretary of Defense Dick Cheney reduced this to 648 aircraft beginning in 1996. By 1997, funding instability had further cut the total to 339, which was again reduced to 277 F-22s by 2003. In 2004, the Department of Defense, DoD, further reduced this to 183 operational aircraft, despite the U.S. Air Force preference for 381. In 2006, a multi-year procurement plan was implemented to save $15 billion but raise each aircraft's cost. That year the program's total cost was projected to be $62 billion for 183 F-22s distributed to 7 combat squadrons. In 2007, Lockheed Martin received a $7.30 billion contract to increase the order to 183 production F-22s and extend manufacturing through 2011. In April 2006, the Government Accountability Office, GAO, assessed the F-22's cost to be $361 million per aircraft, with $28 billion invested in development and testing. The unit procurement cost was estimated at $178 million in 2006, based on a production run of 181 aircraft. It was estimated by the end of production, $34 billion will have been spent on procurement, resulting in a total program cost of $62 billion, around $339 million per aircraft. The incremental cost for an additional F-22 was estimated at about $138 million in 2009. The GAO stated the estimated cost was $412 million per aircraft in 2012. Ban on exports to F-22s during flight testing, the upper one being the first EMD F-22 Raptor 4000, and the F-22 cannot be exported under American federal law to protect its stealth technology and other high-tech features. Customers for U.S. fighters are acquiring earlier designs such as the F-15 Eagle and F-16 Fighting Falcon or the newer F-35 Lightning II, which contains technology from the F-22 but was designed to be cheaper, more flexible, and available for export. In September 2006, Congress upheld the ban on foreign F-22 sales. Despite the ban, the 2010 Defense Authorization Bill included provisions requiring the DoD to prepare a report on the costs and feasibility for an F-22 export variant, and another report on the effect of F-22 export sales on U.S. aerospace industry. Some Australian politicians and defense commentators proposed that Australia should attempt to purchase F-22s instead of the planned F-35s, citing the F-22's known capabilities and F-35's delays and developmental uncertainties. However, the Royal Australian Air Force, RAF, determined that the F-22 was unable to perform the F-35's strike and close air support roles. The Japanese government also showed interest in the F-22 for its replacement fighter program. The Japan Air Self-Defense Force, JASF, would reportedly require fewer fighters for its mission if it obtained the F-22, thus reducing engineering and staffing costs. However, in 2009 it was reported that acquiring the F-22 would require increases to the defense budget beyond the historical 1% of GDP. With the end of F-22 production, Japan chose the F-35 in December 2011. Israel also expressed interest, but eventually chose the F-35 because of the F-22's price and unavailability. Production termination throughout the 2000s. The need for F-22s was debated due to rising costs and the lack of relevant adversaries. In 2006, Comptroller General of the United States David Walker found that the DoD has not demonstrated the need for more investment in the F-22, and further opposition to the program was expressed by Secretary of Defense Donald Rumsfeld, Deputy Secretary of Defense Gordon R. England, Senator John McCain, and Chairman of U.S. Senate Committee on Armed Services Senator John Warner. The F-22 program lost influential supporters in 2008 after the forced resignations of Secretary of the Air Force Michael Wynne and the Chief of Staff of the Air Force General T. Michael Mosley. 57 Nevertheless, in 2008, Congress passed a defense spending bill funding the F-22's continued production, and the Pentagon released $50 million of the $140 million for 4 additional aircraft, raising the total orders for production aircraft to 187 and leaving the program in the hands of the next administration. 2 F-22s in close trail formation. In November 2008, Secretary of Defense Robert Gates stated that the Raptor was not relevant in post-Cold War conflicts such as in Iraq and Afghanistan, and in April 2009, under the new Obama administration, he called for ending F-22 production in fiscal year 2011. Leaving the U.S. Air Force with 187 production aircraft. In July, General James Cartwright, Vice Chairman of the Joint Chiefs of Staff, stated to the Senate Committee on Armed Services his reasons for supporting termination of F-22 production. They included shifting resources to the multi-role F-35 to allow proliferation of fifth-generation fighters for 3 service branches, and preserving the F/A-18 production line to maintain the military's electronic warfare (EW) capabilities in the Boeing EA-18G Growler. Issues with the F-22's reliability and availability also raised concerns. After President Obama threatened to veto further production, the Senate voted in July 2009 in favor of ending production, and the House subsequently agreed to abide by the 187 production aircraft cap. Gates stated that the decision was taken in light of the F-35's capabilities, and in 2010, he set the F-22 requirement to 187 aircraft by lowering the number of major regional conflict preparations from 2 to 1. In 2010, U.S. Air Force initiated a study to determine the costs of retaining F-22 tooling for a future service life extension program, SLEP. A RAND Corporation paper from the study estimated that restarting production and building an additional 75 F-22s would cost $17 billion, resulting in $227 million per aircraft, or $54 million higher than the flyaway cost. Lockheed Martin stated that restarting the production line itself would cost about $200 million. Production tooling will be documented in illustrated electronic manuals stored at the Sierra Army Depot. Retained tooling will produce additional components. Due to the limited production run, there are no reserve aircraft, leading to considerable care during maintenance. Later attempts to retrieve this tooling found that the containers were empty. Russian and Chinese fighter developments have fueled concern, and in 2009, General John Corley, head of Air Combat Command, stated that a fleet of 187 F-22s would be inadequate, but Secretary Gates dismissed this concern. In 2011, Gates explained that Chinese fifth-generation fighter developments had been accounted for when the number of F-22s was set, and that the US would have a considerable advantage in stealth aircraft in 2025, even with F-35 delays. In December 2011, the 195th and final F-22 was completed out of 8 test, EMD, engineering, manufacturing, and development, and 187 operational aircraft produced. The aircraft was delivered to the U.S. Air Force on May 2, 2012. In April 2016, the HASC Tactical Air and Land Forces Subcommittee proposed legislation that would direct the Air Force to conduct a comprehensive assessment and study of the costs associated with resuming production of F-22 aircraft. Defense Secretary Robert Gates had production halted at 187 F-22s, at a cost of $67 billion, to direct funds for ongoing irregular warfare operations in Iraq and Afghanistan. Since then, lawmakers and the Pentagon noted that air warfare systems of Russia and China were catching up to U.S. air superiority capabilities. Previous estimates of restarting production placed figures at around $2 billion, including $500 million in non-recurring start-up costs, with an estimated unit cost of $233 million for a production run of 75 aircraft over 5 years. Lockheed has proposed upgrading the 36 early training model Block 20 Raptors into combat-coded Block 30 35th versions as a way to increase numbers available for deployment. On June 9, 2017, the Air Force submitted their report to Congress stating they had no plans to restart the F-22 production line due to economic and operational issues. It estimated it would cost approximately $50 billion to procure 194 additional F-22s, at a cost of $216 million per aircraft, including approximately $9.90 billion for non-recurring start-up costs and $40.4 billion for aircraft procurement costs. Upgrades. The first combat-capable Block 3.0 aircraft first flew in 2001. Increment 2, the first F-22 upgrade program, was implemented in 2005 and enables the aircraft to employ Joint Direct Attack Munitions, JDAM. Increment 3.1 provides improved ground attack capability through synthetic aperture radar mapping and radio emitter direction finding, electronic attack, and the GBU-39 small diameter bomb, SDB. Testing began in 2009 and the first upgraded aircraft was delivered in 2012. Increment 3.2 is a two-part upgrade process. 3.2A focuses on electronic warfare, communications, and identification. while 3.2b will allow the F-22 to fully exploit the AIM-9X and AIM-120D missiles. The subsequent increment 3.3 may include the adoption of an open avionics platform and air traffic control updates. Upgrades due in 2015 will allow the F-22 to employ the AIM-9X and have full Link 16 reception and transmission capability. The F-22 fleet is planned to have 36 Block 20 training and 149 Block 30 35th combat aircraft by 2016. The Increment 3.2b upgrade planned for 2018 will include a new stores management system to show the correct symbols for the AIM-9X Sidewinder and AIM-120D AMRAAM with improved control of them. In 2017, the U.S. Air Force is defining requirements for next-generation sensors for the F-22, which involves designing new hardware and antennas. Subsequent upgrades are also focusing on an open avionics platform to enable faster future upgrades. To enable two-way communication with other platforms, the F-22 can use the Battlefield Airborne Communications Node, BACN, as a gateway. The originally planned MADL integration was cut due to the lack of system maturity. In 2014, Lockheed Martin and Northrop Grumman were competing to connect the F-22 with other platforms while maintaining stealth. Other upgrades being developed include infrared search and track functionality for the AAR-56 missile launch detector, MLD, and integration of a helmet-mounted cueing system, HMCS, to enable off-oversight missile launches by 2020. Until the F-22 gains a helmet-mounted system, it will use the AIM-9X's helmetless high off-oversight HOBS capabilities. In March 2010, the U.S. Air Force accelerated software portions of 3.2 to be completed in FY 2013. In January 2011, the U.S. Air Force opened the Raptor Enhancement, Development, and Integration (READI) contract to bidders, with a $16 billion budget. In November 2011, Lockheed Martin's upgrade contract ceiling was raised to $7.4 billion. Nearly $2 billion was allocated for structural repairs and to achieve fleet availability rate of 70.6% by 2015. However, only 63% was achieved. Some F-35 technology, such as more durable stealth coatings, have been applied to the F-22. By 2012, the update schedule had slipped 7 years due to instability in requirements and funding. In 2014, the U.S. Air Force moved to cut upgrade funding.